Hello fellow leaders of the web, I'm Nathan Tranquilla. In this video, I will explain to you what exhaustive type checking is, why it is an important feature in a web development language, how TypeScript fails to deliver on this, and how a next generation web dev language solves this issue altogether. Stick around. Let's get into exhaustive type checking, what it is, and why it's important. Exhaustive type checking is when the compiler forces all scenarios to be checked, not just the happy path. And why is that important? Well, you're going to run into runtime errors, unaccounted UI scenarios, for example. It's important to enforce code completeness on behalf of the developer, that every scenario has been coded for. And it's a way of proactively engaging your developers with the problem as opposed to reacting in a production scenario. All right, let's go through a example in TypeScript that I'm calling it a costly example. So here we have the transaction status type. It's a union, and we have a function called update balance, which takes in the transaction status and the balance number and accounts for a few cases, not all cases, but a few cases, pending, approved, and what's missing is the rejected case. And so when we go ahead and plug in a rejected transaction status into the update balance function, we incorrectly get the output of, in this case, 1500. And that is a bug. So it credits the user for a rejected transaction. Now let's take a look at how we would fix this example in TypeScript. So we've got our new updated balance function, and now all three scenarios are accounted for. We've got pending, approved, and the rejected case. So the developer has coded for that case, and all is good, right? Well, the problem is with this is that the compiler did not enforce that the developer engage with this scenario, proactively think through what needs to be done, and instead has allowed, as in the previous case, a bug to go through all the way to production, and now is possibly, in the scenario that we're looking at right now, following up with a code fix, adding the rejected case. So there's nothing that the compiler does to enforce that this be followed. It's simply a matter of the developer having enough presence of mind in the moment to remember to code for this case. Now let's take a look at a example in Elm, a counter example in Elm. So here we have the type transaction status. It's got pending, approved, and rejected, just like the previous example. And we've got our update balance function. We cannot, in the case of Elm, we cannot not code for the rejected case. In this language, each scenario must be coded for the application to compile. Now, what does this mean? This means that the compiler has forced all the scenarios to be engaged with. You can't not code for every case. The developer has had to think through each scenario and engage with it to think about what it means. And the engagement on behalf of the developer has been proactive, not reactive to a production incident. If you want to see more of how next generation web dev languages solve issues and others like it, like, subscribe, and follow me on the journey. Bye now.